So now let's look at an example where they're not going to come right out and just tell you everything that you need to know. So let's take a look at an example here. It says in 1999, 48 million people used the internet for travel information. It says 4 years later, in 2003, that number had grown to 64 million. It says let n of t, so there's our function notation, n of t, which for us is just notation for y. So it says let n of t represent the number of people using the internet at time t. So we have two variables here. We have t and we have n, and we've related those two in terms of a function notation. So t for me is like my x value here, and n, or n of t, is like my y value here. So I still have x's and y values. I'm just using t for time, and I'm using n for the number of people. But again, still function notation. So it says let n of t represent the number of people using internet at time t, where t is the number of years since 1999. So back up here. So since t is representing time for us, in 1999 for us would correspond to t equal to 0, because t for us is the number of years since 1999. And then in 2003, that would be t equal to 4, because 2003 is 4 years since 1999. Just taking 2003, subtract 1999, you'll get t equal to 4. All right, so it says find the linear function. So we want to find something that we can write in terms of y equals mx plus b. Or here, I want to write it with that function notation. I want to write it as y, or n of t, is equal to mx, or m times t, and then plus b. So I'm going to have to find the slope. I'm going to have to find the y-intercept in this case. All right, so just using my function notation. So I have a couple of ordered pairs. It says that in 1999, or t equal to 0, 48 million people had used the internet. So I can write the ordered pair 0, 48. And then it says in 2003, which we said was t equal to 4, that number had grown to 64 million. So I have 2 points on my graph, so I can find the slope between those 2 points. So m, it's going to be the difference in my y values divided by the difference in my x values. So I can do 64 minus 48. Now keep in mind this is in terms of millions, so we'll fix that when we need to. So 64 minus 48, that's a difference in my 2 y values. And then 4 minus 0 will be the difference in my 2 x values. So my slope will be 64 minus 48, which would give me 16. And 4 minus 0 would give me 4. And so this is 4, or in this case, 4 million. So there's my slope. So my slope is 4 million. So basically it's changing at a rate of 4 million per year. All right. So if I go back to my function notation here, it says that n of t, I now can plug in what I know from my slope. So m times t plus b. So n of t is equal to, I'm just going to use 4, and we'll put the millions on there when we need to. So this is 4 times t plus my y-intercept. Now in this case, I have my y-intercept, because remember my y-intercept is where my x value, or for me, which is t, is where my x value or my t value is 0, so there's my y-intercept right there. They gave me my y-intercept. So I just pick off the value for b there, which is 48. All right, so I have everything that I need. So I have that n of t is equal to 4 times t, and that plus 48. So there's my linear function. It's a function of time, so there's my linear function. That's the first thing that they asked me to do, is to find that linear function. So we found that linear function as a function of time. And then the question down there says find a linear function, which we did. And it says use that linear function to predict the number of people that are using the internet for travel info in the year 2020. Now remember that for us, our time is always since 1999. So in 2020, my value for t, if you take 2020, subtract 1999, that's going to be 21. So my value for t there is t equal to 21. So I'm going to take that value for t, I'm going to come over here to my function, and take my function and evaluate it at t equal to 21. I'm just going to take n of 21. So that's going to be 4 times 21, and that plus 48. So 4 times 21, that's going to give me 84. So 84 plus 48. And that's going to give me 132, in this case, million. So 132 million people use the internet for travel information, and will use it in the year 2020. All right, so again, just another application, but again, you've got to be able to process all the information that they're giving you. And again, it's just the function notation. They're not using x and f of x. We're using t's and n of t, but still, it's still function notation. T for me was the years, which is my x value, because I knew that by the notation. N of t like f of x, and then I was just able to process all my information. So you have to make sure you read carefully, make sure you take your time when you're reading this, and make sure you answer the question that they ask you. You're going to do a couple more examples on a worksheet that I'm going to give you in class on Thursday, so you're going to practice this a little bit more. But that's just a couple examples that I want to go through with you. All right, now, before we move on to the last section, before we move on to 7.5, 7.4, I want to add one thing in here that is not on your slide, so make sure that you add this on your notes. I want to look at a quadratic function. And again, back in what I didn't get to in class on Tuesday, I'm going to mention this to you the first thing on Thursday, but I want to go ahead and talk to you just a minute about it while I have your attention on the video. So quadratic function is another type of polynomial function. An example I can give you of a quadratic function is anything where the highest power of x is 2, kind of like the quadratic equations that we've solved a couple different times throughout the semester. So let's take f of x equal to x squared minus 4. From that function, kind of going back to what we were talking about with linear functions, from that function, I can immediately tell you what the domain is, because that's just a polynomial function. So the first thing that I know immediately is that my domain is just like it was with my linear function. Domain is all real numbers. All right, now the second thing is I want to find out what the range is. But in order to find out the range, I'm going to have to graph this function. And to be able to graph this function, I can't use slope and y-intercept because it's no longer a linear function. So I have to have a different approach that I can take to graph this function here. And the approach I'm going to take is I'm just going to make a table of values here for x and for y respectively. So I'm going to make me a table of values for x, and in this case for f of x. And you want to do enough until you start getting the general idea of what this is going to look like. Now I'll go ahead and give you a hint. If you graph anything that is a quadratic function, the shape you're going to get is the shape of a parabola, and so you're going to get something that looks like a U. So that'll kind of help you, give you an idea when you start graphing this what it should look like. But I would just start picking numbers for x and for y respectively until you get kind of a general idea of what this is going to look like. So for example, if I plug in 0 for x, then I'm going to get 0 squared minus 4, which is going to give me negative 4. And again, I'm just picking some numbers at random here. So if I plug in 2 for x, excuse me, I'm going to get 2 squared, which is 4, and 4 minus 4 is going to give me 0. Now I'd kind of pick some random points here. So I wouldn't pick all positive values. I'd pick some negative values as well. So let's move over and let's try negative 3. So if we plug in negative 3 for x, negative 3 squared is going to give us 9, and then 9 minus 4 is going to give us positive 5. All right, so let's look at what we have so far. If we just take those 3 points that we've graphed, then I've got the point down here, 0, negative 4. So down 1, down 2, down 3, down 4. I've got a point there at 0, negative 4. And then I have a point over here at 2, 0. So when x is 2, my y value is 0. And then over here at negative 3, so over to negative 3, then I'm up here at positive 5. So negative 3, positive 5. And so if I connect those points then you can kind of see the U-shape or parabola that you're getting there. Now I have a grid for you on your test, but I'm just kind of giving you a rough sketch over there. So there's my graph of my function. All right, so my domain, like we said, just from looking at the equation, is all real numbers. So let's look at the range of this function. If we look at the range or the y values, then again, I want to see where does my graph cover the y-axis. Well, if I look vertically for my range, then the smallest my graph is ever at is down here at y equal to -4. And then everything above -4, so everything up above -4, I get my curve, or I get my graph that I graphed there in blue. So there's my graph, and my graph continues forever in the positive direction. That's what those arrows indicate, is that my graph is going up all the way to positive infinity. So if I look at where my graph covers the y-axis, it covers the y-axis everywhere from -4 up. And I go up all the way to positive infinity. So I can get my range of that quadratic function to be -4 to infinity, or if you prefer, in inequality notation, that would say that y is greater than or equal to -4. So just another example of a different type of function in a little bit different range than maybe what we've seen so far with some other examples, but I wanted to go ahead and graph a quadratic for you. But if it's not a linear function, you can't use slope and y-intercept anymore to graph this. You're going to have to use some different techniques. And one technique that you have is just to make your table of values. And you may be able to see it with 2 points, 3 points. You know, you may have to graph 5, 6, 7 points until you get an idea what the shape of that graph looks like. All right, so that's kind of 7.3 there. You've got to make sure you know how to write linear equations. Make sure you can write linear functions. Make sure you can take those equations and solve for x or y respectively. So a lot of different application things that you're doing with stuff that you've done before, but just looking at it in a little different way here in 7.3. All right.